Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 4, Variant 1. In the last two videos, we have already discussed about gravitational field, simple harmonic motion, and thermal physics. In today's lesson, we will talk about second law of thermodynamics, we will talk about capacitance, and if we have more time, we will also discuss about electromagnetism. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of A2 physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 4 part A says state two of the basic assumptions of the kinetic theory of gases. Kinetic theory of gases we also call KMT. So we need to state two basic assumptions of KMT. The first basic assumption, we can say particles are in continuous random motion. So we can say the first one, particles are in continuous random motion, and the second one we can say particles we can write down in a little bit different way. So we can say volume of the particles, we can write down in a beautiful way. We can say volume of the particles is negligible, means very small as compared with volume of gas, or we can say as compared with volume of container is very small. What exactly it means? It simply means that imagine that we have this is one container and this container is filled with gas. So there will be gas particles moving randomly. Let's say we have these gas particles. So this is the volume of the gas. Now if we take all these particles and we place them in one corner, so we will have these 5 particles here. So the volume of the particles itself is negligible as compared with volume of the gas. So this is the second assumption. You can also write down this one in a little bit better way. So let me rewrite this one. So this part I want to show you so you can have some feelings about that. You can simply imagine if I take all these 5 particles together, I can simply place them here. So we have one particle here, we have one particle here, one particle here, one here, one here, means just close to each other. So the volume of the particle is negligible as compared with the volume of the gas. So this is the second point. And the third point is forces between molecules are negligible. So we can say negligible forces between particles. We can also write down in detail between particles. You can also say between molecules except collision. It simply means that these particles, they're moving. When they're moving, there are no forces between particles. That when particles collide with each other, that time they exert forces on each other. But before collision, there are no forces among particles. So this is the third assumption we can write down. And the fourth one, we can say all collisions are perfectly elastic. Collisions are perfectly elastic, means no loss of kinetic energy. Perfectly elastic, no loss of kinetic energy. So these are 4 basic assumptions, but for this question simply we need to write down 2 of them. So let me show you how you can write down your final answer. In your answer you can choose any 2 of them. So in a proper way you can say particles are in a continuous random motion. So continuous random motion is very important. Particles have negligible volume compared with the gas volume itself. Negligible forces between particles except during collisions. All collisions are perfectly elastic, mean no loss of kinetic energy. So you have to write down only 2 of them. Part B says an ideal gas has amount of substance small n. The gas is initially in state X with pressure 2p and volume V. The gas is cooled at constant volume to state Y with pressure P. The gas is then heated at constant pressure to state Z with volume 2V. Finally, the gas returns at constant temperature to state X. For part B1, we need to determine an expression for the temperature of the gas in state X in terms of N, P, and V. Identify any other symbols that you use. If you look at state X, for state X it is given to us the volume of the gas. So imagine that we have gas here, and volume of the gas for state X is given is V, and the pressure of the gas is 2p. So we can write on here the pressure of the gas is equal to 2p. So we need to write down expression for the temperature of the gas. So simply we have to use ideal gas equation, PV. This is equal to nRT. So from here we can say temperature. This will be equal to PV divided by N times R. P in this case is equal to 2P. So this one is 2P, and here we have volume. This is divided by N times R. Or simply we can say we have here, this is 2PV divided by NR. So this is the expression for temperature. But in this case we have used this constant R. So we need to state what is R. R is molar gas constant. So you have to write down this is molar gas constant. Molar gas constant. So if you have written this equation, you will get 1 mark, and this one is C mark. And if you have got the right answer and you have written molar gas constant, you will get another mark, and this is a mark. If your answer is correct, you will get 2 marks. Second part says on figure 4.1, sketch the variation with volume of pressure for the gas as gas undergoes 3 changes. The state X is labeled states Y and Z. Now if you look at the given states, we have state X. For state X, it is given to us value of P is means the pressure is 2P and the volume is V. So we can write down V comma 2P. Now if you look at state Y, for state Y it is given to us volume remains constant and value of pressure is P. Volume remains constant, so means we have V and we have pressure that is equal to P. Next one is state Z. For state Z it is given to us the gas is then heated at constant pressure, means P remains constant with volume 2V. So we have volume here 2V and pressure is P. For the final state it is given to us isothermal, temperature remains constant. So this is isothermal process between Z and X, ZX. Between Z and X, this process is means between two states Z and X, process is isothermal, means temperature remains constant. And isothermal process, this is important one, this step you need to understand. Isothermal process, it means that temperature remains constant, so PV is equal to constant. So isothermal, PV is equal to constant. So this is coming from here, means PV, this is equal to nRT. If temperature is constant, R is also constant, N is also constant, it means PV is equal to constant. So it also means that P and V, they are inversely proportional to each other. Inversely proportional. So P and V, they are inversely proportional to each other. Very important point, we need this one to sketch the curve. Now we have state X, then we have state Y, volume remain constant, so at this point is state Y, volume has to be V, pressure has to be P. Then we have state Z, volume has to be 2V, so it will be somewhere here 2V, and pressure has to be constant. And finally we have isothermal, means inversely proportional. P and V, they are inversely proportional to each other. So this will be hyperbola, kind of rectangular hyperbola. So this is how you need to sketch the final curve. So let me clean this one, and this is our final answer. I hope this one is clear to you. So this has to obey PV is equal to constant because this is isothermal process. Third part says during the change of state from Y to Z, the increase in internal energy of the gas is capital U. During the change of state from Z to X, the work done on the gas is W. Complete table 4.1 to indicate for each of the 3 changes of state the increase in internal energy of the gas, the thermal energy transferred to the gas, and work done on the gas in terms of PV, U, and W. So for this one, first of all, we need to understand first law of thermodynamics. According to first law of thermodynamics, delta U is equal to Q plus W, and this W is the work done on gas. Work done on gas will be positive and work done by gas will be negative. So let me rewrite here. Work done on gas is equal to negative of work done by gas. So this is very important. work done on gas will be positive if the gas is compressed. So we can say if the gas is compressed, work done on gas will be positive. If the gas expand, work done on gas will be negative. And work done, we can calculate W is equal to P times delta V. If it is compressed, work done on gas positive. If the gas expand, work done on gas will be negative. Now, based on this knowledge, we can answer this question. And one thing more we need to understand. Delta U is equal to 0 if delta T is equal to 0. As in this case, we have from Z to X, means in this process, delta T is equal to 0. It means that delta U is also equal to 0. From Z to X, so delta U has to be equal to 0. Now we also need to understand in any cyclic process, the second point, in any cyclic process mean in one complete cycle, delta U also is equal to 0. So it simply means that if we start from state X, we go to state Y, then we go to state Z, then we again come back to state X, the same state. So it means the change in temperature is equal to 0. If change in temperature is equal to 0, it means delta U is equal to 0. Now we have Y to Z, delta U, this is positive and this one has to be negative. So here we can simply write down this one has to be delta U negative, because if we add all of them, the sum has to be equal to 0. So if this is positive, this is 0, this one has to be negative. Now the second thing, if you look at from X to Y, X to Y, we can see the volume remains constant. As volume remains constant, means W, this also will be 0 if delta V is equal to 0. So between X and Y, delta V 0, it means work done on gas, this is equal to 0. Now we have to apply first law of thermodynamics for this process X to Y. So we have delta U, that is equal to minus U, and we have work done, that is equal to 0. So how about thermal energy? So here we can write on this one, we have this is delta U. We don't know this one, but we have this one, that is equal to 0. So how about here, thermal energy transfer to the gas, that also has to be negative U. So we can write on here negative U. If you go to Z to X, so we have change in internal energy, that is equal to 0, and work done on gas is plus W. So if we write on the first law of thermodynamics, so let me use different color for Y to Z. For Y, Z to X, we are talking about Z to X. What is delta U? Delta U is equal to 0. What is work done? That is W. How about Q? Sum of these two has to be equal to 0. So this one has to be negative W. Now only we left Y to Z process. So in this case we have internal energy, but work done we can calculate from here. So from here we can calculate work done. So we can write down W, we are talking about Y to Z. W has to be equal to P, means the pressure here times the change in volume. In this case volume is increasing. If the volume increase, gas expand, so work done has to be, work done on the gas has to be negative. So we can say work done on gas, this one has to be negative. So we have P here, this one has to be negative. How about the change? We have 2V minus V. So here we have 2V minus V. So we will get V here. So this is work done by gas, so we will get positive, but work done on gas has to be negative, because work done by gas is equal to negative work done on gas. So we have here, this is negative PV. So we can update here, this one has to be negative PV. Now we need to calculate thermal energy. So the last one, for this one we can use a different color. We can say from Y to Z, we can write down first law of thermodynamics, mean this law again. We have delta U here, that is equal to U. First of all we can write down this is plus U. we need to calculate thermal energy transfer to the gas, and plus we have work done, that is equal to negative PV. So here we need U here, U, so Q should be equal to U minus PV. This has to be U plus PV, yes, U plus PV, because it has to be cancelled. Minus we have here, so this is PV. So now you can see on both sides we have U. So in this case, this is cancelled, this is cancelled. So what is over Q here? U plus PV. So we can simply write down here, this one has to be U plus PV. So this question is simply, you need to understand few points. You need to understand how to calculate work done by gas, and work done by gas is negative of work done on gas. So this is one point you need to understand. You also need to understand how to use first law of thermodynamics. You also need to understand delta U is equal to 0 if delta T is equal to 0. And also you need to understand in any cyclic process, mean if one complete cycle, delta U is 0, because for the same state delta T is equal to 0. So this is how you need to answer. Question 5 says part of an electric circuit is shown in figure 5.1. The circuit is used to produce half-wave rectification of an alternating voltage of potential difference V in. The output PD across 14 kilo ohm resistor is V out. For part A1, a component is missing from the circuit of figure 5.1. Complete the circuit diagram in figure 5.1 by adding the circuit symbol for the missing component. Correctly connected. Very important. Correctly connected. So this is half wave rectification. So it means we can use single diode. So we have to use single diode. So we need to draw the symbol for the single diode. So this is how we can draw the symbol for diode. But if you leave like this, it means this one is wrong. So you have to draw this line. So this has to be a complete line. If you draw like this, for example, as I explained you before, if you draw like this, it means you will lose marks because they have specified correctly connected. So it has to be connected with this wire. So this is how you need to draw. For the second part, it is given to us a capacitor capital C is shown in the circuit of figure 5.1. State the effect on V out of including the capacitor in the circuit. The purpose of capacitor in the circuit is smoothing. So we can say smoothing. So if we have capacitor in the circuit, V out will be more smooth. So we can say V out is smooth. It will be more smooth, means the variations in V out will be small, or we can say ripples in the V out will decrease. Part B says figure 5.2 shows the variation with time t of V in, means the V input. And if you look at one complete cycle of V in, so this should be one complete cycle. So this is how we can draw. So this is one complete cycle of V input. So the time period of V in is equal to 0.04 second, because the unit of this one is second, unit of time is second. Question says figure 5.3 shows the variation with t of V out. In the last part we have discussed that time period of V in. Time period of V in is equal to 0.04 second. Now how about time period of V out? Time period of V in and time period of V out has to be the same. So very important point, you need this one for your exam. So the time period of T out means the output, time period of output also has to be the same. So we can say T V out. So the time period is equal to 0.04 second. Let me explain you this one in a proper way. This is half wave rectified. So this is half wave rectification because we are using single diode. So this is half wave rectification. So this is first thing we need to understand. How half wave rectified signal will look like. So this is how half wave rectified signal will look like. So let me draw with this color. So this is half wave rectified signal. We can also draw the blue line here. So this is our half wave rectified signal. in this case we have a capacitor, so you can see for this half of the cycle there is no V out, so capacitor will start discharging. So in this interval of time our capacitor will discharge. So you need to understand here capacitor is discharging, capacitor discharges, and here from this point to this point capacitor is charging. So you can say from here to here capacitor charges, so we can say capacitor charges, and again from this point to this point capacitor discharges, so capacitor discharges. So the time period in this case is equal to 0.04 seconds. So frequency of Vn, this has to be equal to 1 over t, and t we have that is equal to 0.04 seconds. It means this is 100 divided by 4, so we will get this is 25 hertz. So the final answer is 25. Second part says show that the time constant for the discharge of the capacitor through the resistor is 0.038. So first of all we need to understand where capacitor is discharging. Capacitor is discharging between these two values of PD, and we can find out those two values of PD if we read from y-axis here. So this PD is 5.50, then also we can draw an other line here and we can read from y-axis, and this one is 3.25. So we have value of V naught and we have value of V, and also we can read discharging time from here. Discharging time is equal to 0.02 seconds. So we are talking about discharging of capacitor, so we need to understand V as a function of time is equal to V naught e to the power of minus t divided by RC. RC is time constant. Vt, we have the value of this one is 3.25, mean value of PD across capacitor after time 0.02 second is equal to 3.25, and initial value of PD is 5.50. So here we have e to the power of minus t, and t is 0.02 seconds, and this is divided by RC. We can simplify this one. We can write on here we have 3.25 and this is divided by 5.50, and here we have e to the power of negative 0.02 and this is divided by RC. Now if we take natural log on both sides, we can say ln of 3.25 divided by 5.50, this is equal to negative 0.02 times we have this is divided by, so this is divided by RC, so this is divided by RC. So from here we can find out RC value. If we solve this one, take log of this one and we cross multiply, we can find RC. So let me write down a little bit in detail. So in this case we can write down RC, this one will be equal to negative 0.02 and this will be divided by ln of 3.25 divided by 5.50. So now simply you need to use calculator, and if you solve this one, your answer should be equal to 0.038 second. Then RC, this is the time constant. So here we have 0.038 second. So this is our final answer. And this question has 2 marks. If you have got the right answer, you will get 2 marks. But if your answer is wrong, you have written this equation, you will get 1 mark. So always when you start answering any question, write down the equation, then plug in values and then calculate the final answer. Third part says calculate the capacitance of capacitor capital C. Give a unit with your answer. But in the last part we have just calculated time constant, that is equal to RC. Now we need to calculate value of C. So simply C is equal to tau divided by capital R. R is the resistance of resistor in the discharging circuit. Value of tau is 0.038 and the resistance of resistor is 14 kilo ohms. Now if we simplify this one, we will get 2.7 times 10 to minus 6 farad. So this is the unit of capacitance. So we have to write down 2.7 times 10 to negative 6 and the unit is farad of capacitance. Unit of capacitance is farad. Part C says the circuit of figure 5.1 is modified so that it produces full wave rectification of an input voltage. Suggest with a reason how V out is now varies with time when V in is as shown in figure 5.2. So now is full wave rectification. So we can write down full wave rectification. So we have full wave rectification. Full wave rectification simply means that this negative becomes positive. So this just flip, negative becomes positive. So we will have constant value of V out. V in we have, this one is the V out. We label this one so you will not get confused with V in and V out. So this one is our V out now. This is V out and our V in is the same as it is shown here, means this is our V in. So we can draw here, this one is our V in. So you can see the comparison. That's the reason I want to draw this. So this one is our V in. So this blue is representing V in and the red is representing V out. So this one is V in. I hope you can see the difference between V out and V in. So simply we can say here, this one is constant now. So this is constant. Now let me show you the answer, how you can write down your answer. In your answer, you can mention these points. You can say V in has constant magnitude in both positive and negative direction. Mean this positive direction of V in, this one you can see it has a constant value, and negative also has a constant value. So you can mention this 1 point, this has 1 mark, B mark. Then V out is positive. So let me draw again. So this is our V out. So this one you can see, this one is V out and this is constant. And that's all for today's lesson. I hope this video was helpful and you have improved your understanding of capacitance, and also you have improved your understanding of first law of thermodynamics. If this video was helpful, please like and subscribe, and also leave some comments in comments section. Then also if you have any questions, you can ask in comments. That's all for today lesson. I'll see you in next video very soon, and next video will be coming by tomorrow.